Hello everyone, my name is Godavari Rodage B.Sc. I am student for Rodage College Hingoli in B.Sc second year. My today's presentation is the fundamental theorem of calculus. The theorem statement is a function f is bounded and integrable on closed interval a comma b, and there exists a function capital F such that f dash equal to small f on closed interval a comma b. Then integration of f between the limit a to b equal to f of b minus f of a. Let's solution. Since the function f dash equal to small f is bounded and integrable, therefore for every given epsilon greater than 0 there exists delta greater than 0, such that for every partition p equal to a equal to x0 x1 x2 dash dash xn equal to b with norm mu of p is less than delta. Let mod summation of I equal to 1 to n f of t1 into delta xi minus integration of f between the limit a to b is less than epsilon. Limit summation of I equal to 1 to n f of ti into delta xi equal to integration of f between the limit a to b. Equation number 1. Then for every choice of point ti in delta xi, since we have freedom in the selection of point of ti in delta xi, we choose them in a particular way as follow. By Lagrange's mean value theorem, we have capital F of xi minus capital F of xi minus 1 equal to f dash into ti into delta xi, I equal to 1 to 3 so on, equal to f of ti into delta xi. Then implies summation of 1 to I to 1 equal n into n f of ti into delta xi equal to summation of I equal to 1 to n let capital F of xi minus capital F of xi minus 1 equal to capital F of b minus capital F of a. Hence from equation number 1, let integration of f between the limit a to b equal to f of b minus f of a. It is sometimes referred to as the second fundamental theorem of integral calculus. Thank you.